Look at this photograph. The plow, the oxen, the sheer physical endurance. For generations, Indian farming has demanded immense manual labor to keep the system moving. But muscle and sweat only get you so far. When the rains fail, the ground bakes into cracked earth. A delayed monsoon or sudden drought can wipe out months of hard work in mere days. And the threats extend beyond the weather. An unpredicted swarm of locusts or a fast-spreading crop disease can arrive without warning, stripping a field bare before a farmer even knows what hit them. Despite massive physical effort, the agricultural cycle remains highly vulnerable to things outside the farmer's control. It becomes a game of high-stakes guesswork, simply because critical information about the climate, soil, and pests arrives way too late to act on. That information gap is exactly what artificial intelligence is attempting to close. The predictive algorithms we usually associate with software companies and downtown office buildings are rapidly moving out into the dirt. But we have to ask, can predictive algorithms actually eliminate the guesswork for millions of rural Indian farmers working on tight margins? Or is this another wave of Silicon Valley hype that looks great on a pitch deck but fails in the field? To understand how AI functions in agriculture, we need to look at the micro level. Instead of spraying an entire field with expensive chemicals and hoping for the best, AI allows for hyper-localized, data-driven decisions. This diagram shows how predictive models ingest decades of historical weather data alongside real-time satellite imagery. By processing those overlapping variables, the system pinpoints the exact optimal day a farmer should put seeds in the ground. It also works right in the palm of a hand. Using computer vision, a farmer can turn their smartphone into a pocket agronomist simply by snapping a photo of a struggling crop. The app analyzes the image to identify specific diseases or exact nutrient deficiencies. The diagnosis happens in seconds, long before the damage has time to spread to the rest of the harvest. On the level of an individual plant, these tools act as a highly accurate early warning system. They actively prevent localized crop failure and cut down on chemical costs by targeting only the problem areas. While diagnosing a single leaf is useful, India is facing a rapidly accelerating water scarcity crisis that requires a broader solution. This is where precision farming comes in. In this cross-section, you can see how soil sensors continuously monitor moisture levels. They feed that gradient data directly to an AI system, which calculates the exact volume of water the crop needs right now, dispensing it precisely and avoiding unnecessary irrigation entirely. Now, take that hyper-localized data and multiply it across thousands of acres. All those individual data points aggregate at a central hub, shifting the focus from growing the crop to figuring out what to do once it's harvested. Traditionally, selling crops in a chaotic physical market involves navigating a maze of middlemen and hidden pricing. AI algorithms cut through this noise by analyzing broad supply and demand trends, advising farmers exactly when and where to sell their yield to secure the highest possible profit. Technologically speaking, the science works. It optimizes scarce water resources, protects yields from sudden threats, and gives the farmer actual leverage in a complex market. But a perfectly optimized lab model doesn't automatically translate to a fragmented 2-acre farm in rural India. The reality on the ground introduces severe friction points. Massive adoption is currently blocked by unreliable internet connectivity, low digital literacy, and upfront hardware costs that most smallholders simply cannot afford. This is the exact reason many agri-tech startups fail. They prioritize building highly complex algorithms while ignoring the fact that a farmer's primary concerns are securing a reliable income and building trust in the tools they use. A brilliant piece of code is completely useless if it ignores the socioeconomic realities of the person who actually has to hold it in their hands. For these systems to truly take root, the approach has to adapt. AI tools must be built in local, vernacular languages, and they require heavy structural support from government bodies and farmer collectives to remain affordable. When applied effectively, AI provides the computational power to supplement a farmer's intuition, delivering the specific insights needed to maximize every hour of physical work. The current direction of Indian agriculture is shifting. We are seeing a slow move away from relying solely on generational experience toward a model built on real-time, granular data. But that shift leaves us with a critical question regarding the future of agricultural economics. Will the benefits of predictive algorithms actually democratize farming and protect struggling smallholders? Or will the sheer cost of entry simply construct a wider protective moat for